Okay, today we're going to be looking at the forces involved in collisions. This video relies on knowledge of momentum, acceleration, Newton's second law, and Newton's third law. That's a lot of prior knowledge. If you haven't yet watched videos on those things, click on those videos first. Okay, so we should already know that momentum calculations come in handy when we have things colliding with each other. And when two things collide, they exert forces on each other. So here comes Newton's third law. We should know from Newton's third law that the forces the two objects exert on each other are equal in size and opposite in direction. For example, these two balls colliding, during the collision, the force on ball A is equal and opposite to the force on ball B. So we could ask ourselves, what is the size of those forces? Well, time for Newton's second law. Size of a resultant force on an object is equal to its mass multiplied by its acceleration. Okay, now time for our knowledge about acceleration. Acceleration is the rate of change of velocity, and our equation for acceleration is v minus u over t. So now what we're going to do is we are going to sub that equation for acceleration into Newton's second law. So we get F equals m multiplied by v minus u over t. And if we multiply out the brackets, that gives us mv minus mu divided by t. And we're done. Well, not quite, we need to do an example first. I think all of that is really satisfying. If that makes me a bit sad, I'm alright with that. Okay, let's take our 0.3 kilogram ball and 0.2 kilogram ball from our momentum videos and figure out some forces acting on them. In our previous video, we had an example of an explosion where both objects were stationary and then the 0.3 kilogram ball moved off to the right at 4 meters per second and the 0.2 kilogram ball moved off to the left at 6 meters per second. If the explosion took 0.2 seconds, or in other words, that's the amount of time the two balls were still in contact with each other, what is the force on the 0.3 kilogram ball during the explosion? Again, we need to be careful with direction. I am going to say that towards the right is positive. So, what was our equation for force? We have got force equals, our mass is 0.3, our final velocity v is 4, our initial velocity u is 0, and our time t was 0.2 seconds. So force equals 0.3 times 4 minus 0.3 times 0 divided by 0.2, which equals 1.2 minus 0 divided by 0.2, which equals 6 newtons. Okay, and let's find the force for the 0.2 kilogram ball. This one has a mass 0.2, it has an initial velocity u of 0, a final velocity v of minus 6 because it moved off to the left, and a time t of 0.2. So we have our equation for force, F equals 0.2 times minus 6 minus 0.2 times 0 divided by 1.2. That is equal to minus 1.2 minus 0 divided by 0.2, which gives me minus 6. So my answers were 6 and minus 6. So great, we've not broken Newton's third law. Those are the same size and they are opposite in direction. Now, what's the point in working out these forces? Well, other than to get a good grade in your physics GCSE? Well, turns out there are more important things in the world. And one of those things is human safety. We all know that collisions can be pretty damaging. Let's imagine a scenario where you accidentally crash a car into a wall. What would you do if I told you that in order to reduce the damage on you, you want to be colliding for as long as possible? That is because the force acting on you is given by that equation that we just looked at. So if you increase the time of your collision with the wall, then you decrease the force that is acting on you. And if you decrease the force acting on you, then you decrease the damage. There are certain ways that cars do try and do that. One of those ways is a crumple zone. That is a piece of metal at the front of the car that crumples when you collide with something and increases the amount of time before the car comes to a stop. Okay, I hope you found that helpful. If you like the video, please do like and subscribe. Download the notes for those worked examples. Thanks for watching.